In this project, we looked at designing a swarm of drones to detect landmines. There are currently over 110 million active landmines in the world, and clearing them in a fast and cost-effective way is a pressing challenge. Drones can help clear minefields when combined with a ground-penetrating radar that can send signals under the ground. The problem is the coverage is very small. There's a reason we developed a swarm system that allows us to be more efficient by covering more area in less time. It also allows us to fuse data from different data streams. But designing a swarm to fly together in a reliable way poses a few difficult challenges. For example, how do you make the members of the swarm actually fly together? Turns out flocks of birds are pretty good at flying together. We can implement the way in which they migrate towards a given point and keep their distance from each other in an algorithm. In our case, the drones would just follow a swiping pattern to collectively cover a large area and gather the data. In case one of the systems fails, they will automatically rearrange and finish the job, bringing robustness to the system. But to implement all of this will require communication between the drones in order for them to share the position and be aware of each other. We also need processing power to run the algorithm and store the data. This is the reason we developed a fully autonomous system using another brain, a Linux computer that also runs on autopilot. We relied upon open source software like APM Copter and ROS to build a scalable system that can be used for multiple purposes. In order to control a fully autonomous system, we need the ability to automatically take off and then hold the altitude. We also need the ability to dynamically control the position. The real challenge is to scale up to multiple UAVs. We want to rely on having multiple backup pilots with RC control to be able to fly safely. We developed a framework that allows one operator to be able to control multiple UAVs in a safe way. We have achieved that through multiple safety settings on different levels. For example, if the UAV comes out of a predefined geofence, it stops and lands. The same happens if it surpasses the maximum altitude, or if it loses communication with the ground control station, or another UAV. We also implemented a maximum flying time and controlled for GPS failure and many more. All of this was implemented in a software that runs on every UAV in order to avoid a centralized point of failure. The following example shows how all of this works. With this setup and with the scalable design of the system, we can easily implement new functions to use swarming commercially. We can add cameras and use them for mapping purposes. And we can also do multi-camera filming from the air. We could also use it to collectively inspect infrastructure. Swarm systems have a lot of potential, and this is just the beginning.